Hi everyone, it's me, Carolyn, and in this video, we are going to be looking at section 2.3 in our textbook, and 2.3 is going to be looking at a couple more different types of graphs that we have that are used out there in the statistical world. Some of them that you may not have seen in your high school or educational careers, some that aren't published a whole lot either, but there are advantages and disadvantages to every graph. So we will look at them. I'm going to be using the textbook, much like I did in the last video, to kind of point out some of the highlights and some of the details that go into making these graphs, as well as making them. So just kind of bear with me. I'll also throw a little bit of Excel in there to help us out. Again, statistics, doing it all by hand nowadays is not necessary. In the olden days, even when I was younger, when I was going to school, those tools were not available. So having these tools available to us does make the grunt work a lot less tedious. So first thing I'm going to do is share my screen, and we'll go and look at those guided notes, and we'll kind of walk through some of that. And we are in, there it goes, section 2.3. I'm sorry about that delay in the sharing of the screen. But the first thing we're going to look at is a stem and leaf. Now, the nice thing about a stem and leaf is it does maintain our original data. It does, and I do have an example that we're going to work through, and I might do this one twice just to kind of then talk about some of the other things we have discussed in previous sections and go from there. But this is going to be have 12 cans here that we weighed, and their weights are given, and those are in ounces. I just kind of randomly threw some numbers on a piece of paper. But what I want to do is actually share Excel, just very briefly, on how we can use Excel to help us a little bit. So I'm going to be sharing Excel here. Excuse me. And what I did is I simply just typed in the data. So the 13, the 14, and so on. One nice thing that Excel can do for us really very quickly is sort things from smallest to largest, largest to smallest. So what I just did here is I just clicked on the column. And if you look over here, it does have kind of at the top of the screen. I'm hoping you guys can see this. It has this little sort and filter button. And this works so fast, so slick. We're going to sort this, and I'm going to sort it ascending from the lowest to the highest. Notice they are most of the time thinking we're doing things alphabetical. I have used Excel for like a address book, so then you can sort by last name and then by state if you want to, or you can do multiple layers. So, but we're just going to quickly sort this from smallest to largest. I'm just going to hit this, and you'll see that it automatically did that. And I'm just going to write those numbers down in order on my piece of paper. So when we go back to our guided notes, we have them in order, which is going to save me some time in creating this stem and leaf problem. So I'm going to stop sharing my Excel. But again, Excel is great for ordering things. So again, the ordering button is up here at the top, sort and filter. You can go from smallest to largest and largest to smallest. All right, we're going to go back to those guided notes. And you will see eventually, there they are, that I have ordered this data. And that is just as a step of, a preliminary step to helping me organize this data. Now, stem and leaf, like I said, does maintain all of our original data. So I'm going to just grab this extra piece of paper here. And the reason we call it a stem is because we are going to create this list of data. Now, our stem is going to be the digits at the front end of our piece. Our leaf is the last digit. So a leaf is our single last digit. Okay, and our stem is going to be that first, in this case, that first digit. If we had gone up into the hundreds, I would have also had a 2-digit stem. But I'm going to have my stems as my 1, my 2, and my 3. Again, we should have a title. And I'll put that in ounces. My leaves then are going to be listed in order from the stem out. So just kind of, that's why I like them in order, and I didn't want to do that all myself. So that's why I used Excel to help me with that. So this is the number 11. So 11 is like a 1, 1. There's my 11. Then I have my 12. I have 2 13s. I will list them all. The 14, the 16, and the 19. My 20, my 21, 23. Then we jump up to 30 and 32. So there is my stem and leaf. Now, one thing we do want to include here is a key or a legend for the reader to know, okay, this 1, 1, now is that 1.1? Is it 11 or what is it? So what we would do, and we could pick any number we want. So I'm just going to pick that 23. So that 2/3 means 23 ounces. So you do want to have some sort of key in there for your readers. Okay. If I look at this data, you kind of look at it sideways, you'll see that it kind of has a bunch here and it tails off. This one is going to be kind of tailing towards that right-hand side. So we could say that it is skewed slightly right. So again, we can talk about our shape as well. I did say we were going to do this one twice because sometimes if you have an overwhelming number of data points, like this list goes on and on and on and on and on forever, sometimes you might break it up into smaller groups. So what I could do, and this is just a judgment call on what people want to look at, I could have 2 1s. And I'll put 2 2s and I'll put 2 3s for the time being. Okay. And then what I'm going to do is kind of let the first ones be that 0 through 4. And then last one be that 5 through 9. So that it's kind of like 10 through 14, 15 through 19. Again, we want to keep these sizes the same. So here you'll see that 1, 2, 3, 3, and my 4. The 6 and the 9 would go there. I'd have a 0, 1, 3. Notice we'll have a break here, and then a 0 and a 2. You could leave that one in there as well. But again, this kind of shows the data a little bit. Also can show that there are some gaps. Again, it might even show that, hey, we do have a little bit of a tailing going on because we have a gap and then a couple way down at the end. So you can see that skewness as well. And sometimes when you start it and you change it a little bit, sometimes the skewness disappears. Sometimes it becomes more apparent. So a lot of times when we say things are skewed to the right, skewed to the left, uniform, we're basing it on what we see at the moment. So just be aware that changing the graph slightly can sometimes change the way things look. Again, I would need a title and I would want a key on this one. But, okay, that's the stem and leaf. The next one I'm going to look at is something we call a frequency polygon. And a frequency polygon is kind of a line graph. So it is a line graph. And it's going to be starting at 0. It's going to have some points of the frequencies in the middle of a point of a class. And I'll talk about all this when I show you the example. And we're going to start at the end and at the beginning of the classes. So the example I'm going to look at is one we've seen before. So you may remember those, the amounts of fines. Oops, I'm getting a glare here. Let's see if I can get that glare to disappear. Probably if I turn the light off, then it's very dark. Don't want that either. All right, so we're playing here. There we go. Maybe if I hold it up there. We see those class finds. What we are going to do is we're going to find the midpoint or the middle value of each of these pieces. And to find that midpoint, now remembering these are continuous data, so it's kind of like that whole piece, so all the way from 50, all the way continually up to 75. Our class was 75. What I want to do to find the midpoint is we would take those two lower ones, the 50 and the 75, we're going to add them and divide by 2. So the middle would be a 62.5. The nice thing about having that odd class width is this value here is going to be a value that we could have gotten. So notice we always had 2 decimals because we were talking about money. These numbers will also turn out to be very, very nice. Okay, so you'll notice what we're going to do in this case is we've had these numbers before. We talked about how to find that relative frequency. What we did is created bars in the past. That's what we did. We created a histogram where those bars were touching. We marked them at 50, 75, 100. Kind of bring my paper over here. Kind of draw my little picture, if I can draw this. Again, I'm going to show the books graph because it is so much nicer than mine would be. So I'm just going to kind of draw the first pieces. We had a height of frequency of 1. So maybe you remember this. And then we had a frequency of 7. And we had nothing in that second column. So there's my nice little bars, which they are touching. The next one would have been 10 on top of this. Maybe I'll draw that one as well. So there's our to 150. Okay. A frequency polygon, what it's going to do is it's kind of going to give us a shape without the single bars. So what I meant by it starting at 0 and ending at 0, if you think about what class would have been in front. So here's my 50. These are kind of going up by 25s. That means 25 would have been here. Halfway between here and here, adding those two together, that's 75. Dividing by 2 is 3750. I'm going to put a dot right here at 3750. Then my polygon is going to come and hit at the midpoint, that 1. Then it's going to come at the midpoint and put this value. At the midpoint, it's going to put another dot. And then it connects the dots. Okay, so we can kind of see a curve somewhat filling in our data. And again, we would also then at the end come back to our very last, wherever our last bar was, we would have had a 1 up here, but we want to end again at 0. So it kind of closes out that gap. So I'm going to show you the picture that they did, and you can kind of see it. There it is. Okay, here's that 37.5, that midpoint at 62.5. I did it in conjunction with the histogram, so you can kind of see the underlying histogram behind it. But this is considered a frequency polygon. Notice we have the frequencies along the side. We have our fine in dollars, and these are, again, are the midpoints of all of those classes. So we can kind of see a shape showing up there. If I were to classify this shape, well, it's not really skewed. It's not really normal, possibly symmetric because this hump is kind of reflected there, but not really anything. I think it's just kind of there. Okay, so that is our frequency polygon. Okay, one other type of graph, and actually it's actually 2 in a way, but we're going to we have 2 graphs to talk about. But this next one is we're going to start talking about cumulative data. What happens as we go through the classes and we start adding on the pieces? We will accumulate the pieces together. So we're going to keep working with this same fine data, you know, the fines of our cameras or whatever. And so I'm going to kind of go back. Here it is again. There is our table. We had it to this piece so far. So here's our classes. Here's our frequencies. We turned them into relative frequencies. Again, how we did this, we took the 1 divided by our total. We had 50, so we kind of divided by 50. Okay, and what we can do is we can accumulate our data. So think about it as almost a snowfall. As we go through, we're going to just keep adding on extra snowfall. So here, when we get through this one, we had 1 person in here. When we get to here, we aren't going to be getting any extra snow, so we're still going to stay at that 1. In cumulative data, we do not melt, so it will stick on the ground and just keep accumulating. Then we added into another 7. So that's why we went from 1 to 8. We are accumulating or adding on the next 10, adding on the next 5, adding on the 4, and so on and so forth until, notice when we get down here, we have all of our 50 people or 50 people included. So there is our cumulative frequencies. We can also have cumulative relative frequencies. Notice we should always end with a 1 because that is kind of like 100%. And we can graph this data with something we call a frequency or relative frequency, depending on which set we use. We use our frequency numbers or our relative frequency numbers. And these are pronounced as an ogive. I did kind of write that in our notes here. It is an ogive. Okay, so we're going to be using that frequency to accumulate as we progress through each class. The way we do that is we are going to start at 0 at the very beginning, and we're going to accumulate as we go. So I'm kind of going to show you, and what I'll probably do is show you on a separate piece of paper kind of starting. Because the graph, they kind of have it small, so it's a little hard to see. So here we are. There's my number line here. Slide this over. And here was the beginning of our class, that 50. Here was that 75. Here was that 100. Here was our 125. And so on and so forth. The way they like to do this, and I've seen it done a couple of different ways, is they will start right before this class. So right before this class would have been the 49.99. Okay, so remember we would have gone from 25 up to 49.99. This one went from 50 to 74.99. So we're going to start at 0. By the time we get to here, right before this class, so at that 74.99, right here, we're going to be at 1. So if I have my scale here, this is going to be at 1. And what we're going to do is we're going to connect our dots. So you can kind of see accumulations growing as we move through the data. Then we notice we didn't add any more on. So when we get here at 99.99, 99.99, we're still at 1. When we went through this next class, we added in another 7 people. So we're going to be up here at 8. So 124.99 up here at 8. By the time you get to the end of the class, we're up to 8 people. And we will keep accumulating these until we have dots at those end of the classes, starting at the end of the class as right before where we start, and keep accumulating, and we'll accumulate all the way through. So to see the finished product is right here. Okay, so notice there's my 49.99, 74.99. So those are the end points of the classes. We started at 0. We added 1, didn't add any more, added 7, added 10 more, and so on. This one happens to be the cumulative relative frequency. So notice we have those decimal pieces. Okay, you can also do this with the frequencies as well. So we would have had like this 0.2 would have been probably about 10 or something. So, but here would have been that 0.16. If we wanted to label this, we would have been at a 0.02. And we could have added all those as we went along. So here would have been my 1 and my 8 and so on and so forth. So how you label this or scale this will depend on if you're going to use the cumulative relative frequencies or just your frequencies. Okay, we can do this in Excel. I will show you that in a moment. But before that, I do want to just show you one last graph in the textbook and work with that. And that is the last graph in this text, in this chapter, is something called a time series graph. I'm not going to spend a lot of time on it. Basically, it is a line graph over time. So, for example, here is a time series. Notice we have time going on here, and then whatever we're talking about along the timeline. So it's just a line graph over time. And that is something that's shown over and over and over again to help us out. Okay, I am going to shift back to Excel to help us look at how to graph those, like that ogive. Maybe doing it in Excel to help us out a little bit, or maybe even doing the relative frequency graphs where we're doing the midpoints with those dots. And we can easily do that in Excel. So I'm just going to start us so you can see. And so we'll go into Excel. I'm going to have to do some typing in here. But let's just say we were going to do the ogive. Okay, and so we want to make sure to get, we might have to do a little bit of work ahead of time. So we'd have that frequency table with us, probably with all the cumulative data in there and so on. So I'm going to take my book and I'm just going to be adding some of that in here. Since the ogive has the dots at the end of the classes, there's, oops, not this one. I got to type right here. So we'd be at 49.99. Got to type correctly here. And then we'd go up to 74.99. You guys can see how terrible my typing skills are. And we'd be at 99. And then I'll do one more here for us. So 124. And I'm just going to put in the cumulative values. So remembering we want to start at 0. By the time I hit 74.99, we're going to be at 1. We don't add any more in. So I'm going to put the 1 in there as well. Oops, where'd it go? And then we do accumulate and we get up to 8. And we could continue. Maybe I'll do one more here. So this would have been 149. And this one is now at 18. Okay. And to do these graphs, they are simply line graphs. I'm going to grab my data. Oops, just grab my data. And I am going to insert a chart. Now, in the chart that I want to do is I do not want to choose the line graph. Even though we're drawing a line graph, Excel does a horrible job at doing a line graph. And I'll show you why, just so that you can understand this is not the way you want to go. There's my line graph. I don't have titles or anything like that, but you'll notice we have 2 lines. And what's happening here is it is plotting the number 1 with the 49.99, the 2 with the 74.99, the 3 with this one. It is also doing 1 with 0, 2 with 1, and so forth. So here's that second line. That's not the data we wanted. So the easiest way to get a line graph the way you want it to be in Excel is to actually choose the scatter plot or bubble chart. So I'm going to hit the scatter plot and I'm going to pick the one with the line option. So there is the data that I want. So you can kind of see that accumulation going as we move. It did start at 0, stayed at 1, jumped up to 8, and so on. We would want to trim this a little bit, so make sure we don't start too soon because we don't like to see a lot of empty data. Possibly get it to label so these values actually show up. So this would be that 74.99, and you can play with that with your labeling and so forth, and stuff like that. So again, when you are creating these tables or charts for me, I am not going to expect that you are a chart wizard or a graphing wizard. I'm going to look for the basics. Excuse me. If you want to do things by hand, feel free to do that as well. So again, just kind of recap this section. We talked about our stem and leaf. Our stem and leaf graph has that one single stem with the leaf. If you were doing a comparison graph, you could have a single stem or your stems in the middle, and then your leaves would start on the near those stems and order out. So maybe you had the male versus female, so you could go in both directions to kind of compare. So that I've seen done as well. We've talked about ogives, relative frequency graphs, and so forth. The next video that I'll be talking about in this chapter, which is the last one, will not have any guided notes, but we're going to look at just some ways that graphs can be misleading or distorted, might be a better way of saying it, but that's in the next video. I hope to see you there. Hopefully you're doing okay so far in this course. If you do have any questions, please email me so we can get you caught up, get you squared away, get you unconfused, and all of that stuff. So again, see you in the next video.